Assalamu alaikum everybody. In this session I'm going to show you how you can install DOSBox and the related assembly language softwares for your lab work. So let's start. Okay, go to your Blackboard portal and access your course, the Computer Organization Assembly Language Lab, and then move to lectures, and in lectures you will find these two, the assembly folder and the DOSBox software. What you need to do is to download these by clicking on it, and once they are downloaded, then we can proceed with the installation process. So quickly do it and let's see the next step now. Okay, you can see here the DOSBox .rar file is here, and I am trying to extract it. So what I can do is double click on it and it will show you the installation process. You just press next, then next, and then install it. This will install the DOSBox on your C drive. You just press close here and it is going to appear on your desktop. You can see it here. I'm going to show it to you again. What you need to do is you are going to click on this, okay, you can click on it and this will appear, and you will just press next and next 2 times, then it will be installed on your C drive and the installation is completed. So just close it, minimize this, and you can see that okay. Next, your other file, this one, the assembly language file, what you need to do now is just double click on it and it will open this file. And what you can do now is you can select this file, press extract to, and select any drive you can see here other than the C drive. If you have E drive, F drive, it should not be C, other than C drive. Okay, so this is one thing which is important. So just make sure that you are not extracting this folder on C drive. Okay, so I'm selecting this E drive and I have made an assembly folder. Then I'll press OK, and all the files will be extracted to this folder, and you can see all the files are here. So this AFD is here, the A-link, exit, and all the other software file, and this code QQ is the base first code, which assembly language code which we are going to use, and with an extension of this. Next step is to double click on the DOSBox and you will see this screen appearing on your display, and the next step will be to mount the drive. We are going to create a virtual drive, and you're going to type here mount B E : / assembly and enter, and you will see the message drive B is mounted as local directory. The next step is to go to drive B by typing B : enter, and you can see that you are in the drive B, which is the virtual drive, and we are going to use it for further steps. Okay, Okay, next thing is that you need to have some code, and basic code is provided in the assembly folder, so you can just check it out. You can double click here and you numbers and subtract a third one from the sum using registers. I just want to clear one thing here, that in assembly language, after the instruction there are two positions. One is called the source, sorry, destination, and the other one is the source. And you need to remember this, that it's going to be like this. The direction of flow will be like this. It means that this 5 will be transferred to AX, because 5 is the source and AX is the destination. Same is the case if add AX and BX you take, then contents of AX is 5, content of BX is 12, so 12 and 5 will be added and the data result will be stored in AX, because AX register is destination here. Okay, so on the left side there is destination, on the right side is the source, so you need to remember this. Okay, so the next step will be to assemble this program, and for that we know that the name of the file which we are using is the qq.asm. so I'm going to write the command here for you, and you can see that this is the command. You can see by pen just execute, and this has been executed. And if you go and check the folder, you will find this abc.com file. Okay, the next step is to open this file in your AFD, and the method will be, you can do that AFD and the output file which you have just created. So we are going to do that, and after pressing enter you will see it open. Okay, few things I want to explain here. First is that you can see these are the section which is, this is the section which is showing you registers, and you can see AX, BX, CX, DX, and later on we will be using SI, DI, BP, SP, CS, DS, ES, and SS, the code segment, data segment, extra segment, stack segment, instruction pointer, and all the other registers. But for now today we are going to be looking at these and trying to figure out your results. Okay, so, and the other thing is that this section is showing you the instructions which you have loaded. Okay, I'm going to show it to you so that you can just see how it is working. And you can see this is the instruction. You can see here that it is move AX 00005. You just put 5, but it is 0005 because it's a 16-bit and every digit is showing you 4 bits. So 4 4 4 4 16. So AX is a 16-bit register. That is why it is filling it completely with. Then you can see this. The next move BX 12, and 12 is equal to C in hexadecimal, so it is converted, and the values you are going to see here are going to be in hexadecimal, so you need to know the conversion also. Anyway, the next instruction you can see here, the add instruction is here, add AX BX. Then we have move BX14, move BX14 is here, move subtract BX AX BX, subtract AX BX is here, and then you can see this 4C service moving into the AX register, that is the AH part of the AX register, because services are moved to AH first before they can be executed, and using the interrupt21 command you are going to execute this instruction. So this is important that you know where your program is and where your results are. Okay, after pressing enter you will see it opens in this IDE, and in this execute it. So fun instruction executed, and if you check the AX register you will see that, you can see that AX becomes 005. If you keep on pressing the F2, then you will see that all the registers, like BX, check BX, it's now 0C, which is 12. Then next instruction, and it becomes AX becomes 11, because 11 is equals to 17, and we were adding 5 and 12, 17. So in hexadecimal, 17 is equals to 11. Then we move 14 into BX, so BX content should be becoming 14 now, and you can see here that it has become E, which is equivalent of 14 in hexadecimal. And finally, if you carry on, then all the subtraction, and finally the interrupt 21 executed after the service 4C was called, and you can see the program terminated normally. So you can check the results before termination of program, otherwise all the registers will be resetted. So this is the way you are going to proceed with this first lab. I hope this is detailed enough, and if you follow it step by step, you can watch this video as many times as you want, follow it and try to implement it. Okay, then thank you very much. Allah Hafiz.